Thank you, Tom. First, I want to acknowledge my collaborators here, Mike Morley, Maya, Alan Rempel, Tom Dakin, Richard Dewey, Raina Jenkins, all of our software development team, the metadata team, the data team. We have a lot of people working on all sorts of stuff at ONC, and it's been a great environment to work in. I'm currently working as a software developer, more so than acoustic scientist, so this is kind of a software developer talk. If you guys have seen this figure a couple times already, Ocean Networks Canada operates cable observatories on 3 of Canada's coasts, all 3 of Canada's coasts. We have small sites like the community observatories and then our large cable array. We get a lot of data. We have over 400 instruments, 100 different types. One of the cool things is that we are able to support all these different types of instruments, from the simplest to the most complex. I think we now have over 5,000 measurements. Tom said 4,000. I think I rounded up maybe. We make 10 million measurements a day, 300 gigabytes archived per day. That's up again. And then we got about over 700 terabytes of data archived so far. The majority of this data is complex data. We call it complex because you can't parse it into a single reading per time. So that's video, radar, acoustic data, and hydrophones predominantly, 300 terabytes hydrophones. We also have 25 terabytes of active acoustic data, including single beam, multi-beam, imaging sonars, and the new Eris sonar that Xavier talked about yesterday. Oceans 2.0 is our data management and archiving system software. It's an all-encompassing piece of software that runs on all the servers. It takes data from the observatory, archives it, enriches it, puts it out into a portal, and then you can get all these data products from it. A little bit more detail about the data acquisition process. We interact with devices through the data acquisition module. This is a Java development diagram. So after that, we parse, calibrate, detect events, apply QA/QC, archive it, and put it in the file archive and a Postgres or Cassandra database. This operates on like 5 different servers in a chain. The data is passed through an ActiveMQ bus all throughout the internet. So we're really operating an Internet of Things because we have observatories all over Canada. All the data goes through the internet and is connected through ActiveMQ. Now, how do you get the data out? We have this data product pipeline. From the file archive, the various databases, we can pre-generate data products with our task server pool. We have on-the-fly data products that users can request through the data portal and then download to their laptops. Most of our data products are actually generated in MATLAB, which is what I do. Here is some scalar data, just to give you a little preview of what you can get on our site. This is the ice profiler that lives up in Cambridge Bay. It sits under the ice, looks up at the ice, and measures the distance between with just a simple echo sounding compared to a pressure measurement of how deep the water is. You take the difference of that, you get the ice draft. And every year you can see that the ice grows, and actually it's getting less and less ice every year. And one of the cool things is you can see this is a CTD that measures the salinity. As the ice grows, the water gets saltier as it pulls fresh water out of the seawater. It's pretty fun. I'm going to show you some examples of our pre-generated data products. This is we call it a Bioacoustic echo sounder, but it's the ASL AZFP. This is from yesterday, so it's live, almost live data. You can see deal patterns in the zooplankton migration, 3 different frequencies, an RGB composite where the redder guys are bigger, the greener guys are bluer guys are smaller, and you can do sort of bioacoustic stuff with that. The deal pattern correlates directly with the sun elevation there. We have a lot of ADCPs on the network. Here's an example one from the Strait of Georgia. You see tidal patterns. There are internal waves and all sorts of other fun things going on in here. Here's an imaging rotary sonar. This will play for actually quite a few minutes. I think it's 2 minutes long. But this is the Hydrate mounds. It used to track the Wally crawler. You would drive along here and you could see it in the rotary sonar. And you can also see fish and other stuff going on. And if a hydrate mound actually let go and flew away, you can probably see that too. So I'm going to get to some hydrophones now. This is a daily spectrogram from Barkley Canyon. There's probably a ship driving through there. And one of the real cool plots we make is this spectral probability density diagram, which shows the density of the spectral information over frequency. This is for 1 day of data. We generate these daily as part of our quality management process. This hydrophone is extremely quiet right now, nothing going on. And if you want to download the data, you can go to our Search Hydrophone Data tool and preview the spectrograms and download small bits of them. The data search tool, this is step 2 of it. Step 1 is to find the data. Step 2 is to download the data, give you all sorts of products, all sorts of modes, and you can get all sorts of stuff this way. So now that you can access the data, how do you want to be assured that the data is of good quality? Well, we go through this quality assurance life cycle where we acquire data. Once we acquire instruments, we carefully acquire the best instruments for the job. We develop the driver software to interact with the instruments, and also part of that we develop data products hopefully before they go in the water. It doesn't usually happen that way. And then once we're kind of getting the software going, we can put the instruments into a test phase in the tanks at MTC or in short deployments just out of iOS. This is installation up near Sydney. And when we put the devices in the water, we have a commissioning phase where our data scientists go through and check all the data, make sure it's all good. And then we do recovery, servicing, and cycle. One of the things we're doing now with the shallow installations is that we're swapping out entire platforms now. Adrian was talking about that recently. And it makes the ship time much less. They don't actually scrub down the instruments on the deck and all that stuff. They just pick the whole platform up and put a whole new platform down. The whole platform is tested in situ in the tanks at MTC prior to going on the ship. So it makes a really good quality installation. Everything works when we plug it in. To make sure that we track all of our steps when we do all this work, we have a workflow tool that's in Oceans 2.0. In this case, the metadata team, data teams, they go through and they fill out all these steps. They track all their progress. They have procedures documented and version controlled. We have automated tests that go through the scalar data system and look for abnormalities. We do range tests and all sorts of quartile tests. We make careful tracking of the metadata. The metadata system has all sorts of information about the sites, deployments, including calibration. This is a bunch of calibration data for our hydrophone. We calibrate all of our hydrophones, and all that calibration data is available as well to download. And how do you calibrate the hydrophones? Here's my segue. We have a new hydrophone calibration system. It's basically this yellow box here that Manuel and Tom built. It works with pulse tones to interrogate a unit under test, and we compare it to a reference sensor. It can be a pressure sensor or a another calibrated hydrophone to compare to. It works on digital and analog hydrophones. The low frequency mode we have, it uses this benchtop unit right here. You plug the hydrophone in very carefully, and it can calibrate from 0.1 hertz, which is, Tom tells me that's very unique, and up to 2 kilohertz. The HF mode, you can put the hydrophone in a tank or hang it from a boat and do it that way. And I've been busy working on this. This is the software for the box. You interact with it, run the tests and all that stuff. So now that everything is calibrated and you can get the data, what if you want to do lots of it? Well, you can do that through the API, and that's the application programming interface, which is basically all the web services that you can use. All our web services are RESTful JSON, which is a human-readable format, and everything you can do in the data portal, all the screenshots I showed you, you can do in the API as well. The major steps for doing this work is to look in the discovery services and then grab the data with our delivery services. And here's the list of all the discovery services, delivery services, and the cool thing is these client libraries that you can download to work with the API more effectively. Now you have the API and you get lots of data, you're going to get overwhelmed, right? You could get 300 terabytes of hydrophone data and not know what to do with it, or run out of space on your computer. One of the things that we find that users have trouble with is actually the speed of download isn't as fast as you can actually process the data. There's a limiting step there with the input-output. So one of the things we want to do is move the processing to the data. If you can run your code on our servers next to the data without having to move the data, it can save you a lot of time. Problem with that is if you can run code on our servers, it can be a big security problem. So we sandbox it with this Docker software. We run it on a separate task server, and the Docker container is only limited to accessing the API. You can't check out the other file systems or snoop on other things. We support major languages R, Python, MATLAB, C++, and users can actually share their sandboxes. So the idea here is that users will develop and test their own code on their own machines. You can just grab little snippets from the API, develop your stuff, and then when you're ready, you go here and you upload your source files, you choose a command to start it, and further down the page is a scheduler. You can schedule it so you can run this stuff daily, every 5 minutes, whatever you like, and then it'll produce data products for you. And here's a little example of how it looks like when it's actually been run. A little diagram of how you upload your code, download your results through FTP. What I'd like to see is people be able to put up their data products on websites and stuff like that, right? So you can ship your code to our servers, and then on your own website, you can show up the data products, right? That'd be awesome. The current version is kind of a prototype. The big thing we got to add is GitHub integration so we can move our code back and forth really easily. And we've got 2 nice use case examples if you want to use it, try it out, and give us a email if you want to try it out. It's not totally open to the public. All of our other stuff is anonymous access, but the sandbox, for some reasons, is contact us to get access for it. And through this system, we hope to facilitate collaborative code development and further the use of our data. Thank you.
Any questions for Ben? Super exciting. Thanks for a great talk. Seems like the right general direction. Seems like usually the data product from an algorithm in real-time analysis or archive data ultimately generates an annotation. And hopefully all annotations across the planet will be synchronized in time. So I'm wondering if there's a vision for using the API to change annotation in fluency data instead of AI data. Because ultimately, with some species of fin whales that have migrated across international boundaries, we want to be able to understand both time and space, say, very different fin whales across the planet. So do you have a vision for how, you said data products are moved websites, that's good stuff. It seems like ultimately we'll be sharing the data that creates the data products and then surfacing that everywhere. And everyone can do websites, just collaborating on it.
Yeah, we have an annotation system. It's pretty extensive. Maybe when I showed the Search Hydrophone page, there's actually annotations built into that. You might have seen the little link. It says annotations in Data Search 2's annotations. Raina would be the best person to talk to about sharing and cataloging all those annotations. They're doing a lot of work to have standards for interoperability and all that stuff. So yeah, it definitely exists. It's definitely on our radar.